All right, well, welcome, everybody. We should move closer and have a nice conversation here. I have a lot of slides to roll through. I have a lot what I call leave behind stuff, right? So I'm going to cover a lot of material. I'll cover it quick. If there is something on here that I'm blasting through that piques your interest, just raise your hand, say hello, ask your question. Don't feel like it's an imposition to interrupt me. Okay, so we'll go. So this is healthcare and medical device cybersecurity. I'm Phil Englert. I'm the Vice President of Medical Device Security for Health ISAC. I'm a clinical engineer by trade. I fixed clinical diagnostic devices for a number of years, managed biomed programs in hospitals, first one, then four, eventually 14. Before Catholic Health Initiatives was formed. Catholic Health Initiatives was a 100+ hospital system in 19 states. I built the CMMS. I didn't write the code, but I did all the specifications. We had a custom CMMS system. And then I did all the operational benchmarking. I also managed our equipment planners. We had a technology assessment team. I used to call myself the director of leftovers because all these little pieces and services that we offered for our organization, I got tasked with it if it wasn't directly related to turning a wrench and keeping the lights on. So Health ISAC is a member-driven organization. But before I get into this, I know I've got one rad maintenance tech in the room. I've got one rad director in the room. How about the other folks here? Are we operating or maintenance? A rad tech, some kind of technician, and a student, right? So very good. So a little bit about the audience. So we're a membership-driven organization. We've got almost 800 organizations, healthcare organizations in the healthcare sector. In 2013, presidential decree created what they called critical infrastructure, right? Transportation, nuclear, utilities. Healthcare is one of them. There's 19, I think, critical infrastructures. Healthcare is one of them. If you have a role in patient care, i.e., we used to say if you manage a patient ID record, then you're in. We include, everybody: pharmacy, biotech, healthcare providers, medical device manufacturers, and we bring them all together. My job is to bring the producers and the consumers, the users of med device together to look at what are the challenges of securing this in our environment. I just saw a statistic, ransomware, right? And this is globally, right? Just hit 1.1 billion with a B dollars, globally. So it's massive. People are into it, right? And medical devices, because of the way they're configured, are not always the most protected devices in your environment. Right, so a little bit more, it's an information sharing analysis. We are a safe harbor sharing space, right? Meaning that our members can, reveal their secrets, right? Without any risk of regulatory or legal response, right? So it's really, really good. We cover probably 80% of the beds in the United States are members. Many organizations, and I can't say who, what organizations we have. It's just one of our things. But many organizations are in. The IT team knows about it, and nobody else in the institution knows, right? So you should check. You can see that there's a number of different ISACs. The auto ISAC, retail and hospitality. There's multi-state. There's all kinds of them, right? And they all do the same thing. We're interestingly enough, we're kind of our leader. Denise Anderson, our CEO, right, is the president of I forget what they call it, organization of ISAC. So all the ISACs that come together, she's the president. She came out of the financial ISAC. Our CSO came out of the financial ISAC, and we're providing services, and the other ISACs are coming to us going, how are you doing this? How are you doing it so well? We've got about 10,000 people globally. So we serve not just, it used to be the National Health ISAC, and it's just the Health ISAC. So we're a global organization. Again, this goes to, rad centers, hospice, clearing houses, everybody that has a role in providing healthcare, right? To us are in. some of the things, the pharmacies, the big medical device manufacturers. Interesting thing, right? There's probably about 3,000 medical device manufacturers for software-enabled devices alone, right? So it's a startling number. In a place like St. Joe's Providence, right? Large hospital system, right? I'm gonna guess that for connected medical devices, you have probably 400 to 600 different manufacturers, maybe 12 to 1,500 different makes and models of software-enabled medical devices alone. This isn't even talking about just, you know, the pneumatic stuff, or is there any of that left? You know, but some scapulas and Band-Aids and drapes and stuff like that, right? You can also see the organizations that we have. So these are by tier. Obviously, the bigs, there's not that many of them, so there's fewer. You know, so that just kind of shows the distribution of that we serve. We really like to leverage, you know, the resources and the expertise that reside up in here, because they've got the big bucks, and then bring that knowledge down to the little folks, the folks that don't have those kinds of resources, right? So we're really about building, and it's not just cybersecurity stuff, it's policies, it's practices, you know, it's how do we get stuff done. When large language models and ChatGPT came out, everybody was like, what kind of guardrails do we have to put around that? We just stood up a group and said, hey, you guys figure it out, and they produce artifacts so that, you know, when it becomes important to you, you've got a resource to lean into. So really cool. So board of directors, just put that up there so you can get an idea. I can't really tell you who our members are, but you can tell they're not on the board if they're not a member. But there's another, you know, 790 organizations included here. So healthcare and cybersecurity, that's what we're here to talk about, right? Right up the road, Hollywood Prez in 2016 got hit with a ransomware, right? It shut them down. They just didn't know. This is a large urban facility, right? Multicultural, serving the underserved, you know, and all of a sudden they're on divert. They're taking patients out of the hospital and figuring out where they can send them, right? This is a big deal. This is a big deal. 10 days, right? FBI, law enforcement called in. They paid 40 Bitcoins at the time was worth like $17,000, right? The bigger impact, what's their revenue per day? About just a little shy. At the time, it was a little shy of $1.5 million per day, right? So in the course of 10 days, $15 million right out of their revenue bucket. You know, that's tough. That is tough to swallow, right? Let alone reputational damage, let alone, you know, the diversion of patients that go elsewhere. You know, I'm now going to go somewhere else for care. So, and this was right out of Word is how it came. It's a Locky thing. Anybody know the first attack on a healthcare system in the United States? It happened to a children's hospital in Boston, Massachusetts. In what was this? This was 2016. This was 2014. So just a few years before. And it happened because this hacker in the middle of Massachusetts, his daughter was not getting the treatment that he thought she needed at Children's Hospital. And so he just went in and smeared their webpage, just totally disabled it, put all kinds of messaging on there. So that was like the first hack. The first hack in healthcare, right? This is pretty funny, right? At a convention, not unlike this, right, of scientists, medical scientists that all went. It happened in Sweden, and this guy dropped floppy disks, gave infected floppy disks to all of his peers. You know, so now they tell you don't pick up the USB in the driveway. You know, back then it was you don't even know what a floppy disk is, do you? So, so 3.5 by 3.5 card, right there. So anyway, kind of funny. So here it is, breach, right? We're getting pretty good. This says, look, you know, the number of breaches has gone down, right? But on there, and you can see that it's not just, you know, it's not just healthcare providers, right? Over here, look at the number that business associates have grown So as we digitalize healthcare, as we get partners, as we stop building data centers and start relying on contractors to host all of our stuff in the cloud, you know, we've got all these business associates that do more and more for us. And so that's a larger threat surface for us, right? And the funny thing about HIPAA is HHS holds the healthcare system accountable, not necessarily their business associates, the people they contract with, right? So it's a tough thing, right? And you know, we're victim bashers, right? In my opinion, right? And this is just my opinion, not Health ISACs or anybody else's. HIPAA needs to go away. We should just look at sensitive information as sensitive information, regardless of whether it's healthcare or just my social security number, my birth date, the rest of my sensitive information. If we broke that, and there's way too many people making too much money to let go of that, right? It's not going to happen, but that's really what I believe should happen. But here's the thing, right? The number of records impacted, right? The blue line is your business associates. So as they grew, all of a sudden they're doing more and more business for us. They're the ones that are leaking the data, and you know, they're not. Attackers aren't stupid. They're going to follow the money. They're going to go where the records are. They know that in healthcare, we've got to get it back up and running like pronto, right? So a couple things. This is a nice thing here. This is one of the few surveys I find on medical devices, but they're opinion surveys. What do you think? Are you changing passwords? We have very little empirical data around medical device security as a whole. So this is the best we have for now. I'm working with the Healthcare Sector Coordinating Council to help fix that, you know, but again, HHS, when you report a breach, they don't have a category to say medical device involved, right? You can say computer, you can say server, you can't say medical device. So there's no way to record a breach on that. And in the FDA, in their MAUD reporting, where there's an adverse event, medical device or cybersecurity incident is not a failure mode, right? So in there, so they can't, you can say, yeah, we had an issue with our medical devices, you know, but you can't say it was a cyber incident on that. So the FDA is not collecting that information and HHS is not collecting that information. So we just have this information gap, right? And I'll be honest with you, I talk to physicians a lot, you know, and I say, hey, if a device were to fail, we were just talking about interventional labs, right? I said, if a device were to fail in the middle of a case, right, would you ever consider cybersecurity? And unanimously, they all say, I have no training, exactly. I have no training, I have no perspective to even make that judgment. And so they don't go there.
I think that's one of the major problems I feel is we do online basically training on security of our computer, right? But you have no one to come out and say, you know, you did the training, but did you realize what you were training on? Whether or not to take that sound drive that you took from your house into that unlocked computer and say, oh, I'm safe. But I think that one is the knowledge level of the end user. That be a X-ray tech, lab tech, anything.
Right.
It's not, it just can't be a 1 year thing. It's got to be a kind of a rotation of personnel on a constant basis.
Exactly. Exactly. Do you know, like do you know why they require CPR training every year?
Well, we don't keep your skills up.
To keep your skills up, but why? Because if you don't use it after a year, your retention level is like 10%, right? So you've got to do it. Exactly. You've got to do it. You've got to keep it in front of your folks. Hi, welcome. Your role in your facility? Are you a, okay. Okay, nice. Thank you. Thanks. So, so yeah, so training and all of that needs to be like repetitive, right? You just have to get it there. The other thing is tactics and techniques are constantly changing, right? So keeping people appraised of what are they doing today, right? I mean, how many folks have got the text from their boss that says, oh, hey, you got an hour? Can you go down and buy some, you know, gift cards, you know, and then get them? I mean, they're spoofing your phones these days. The techniques are crazy, right? So, but you know, we're not changing passwords, right? medical devices, less than a third are being patched, right? And this is a challenge for two reasons. One, manufacturers are slow to come out with patching, right, and updates, right? And they usually, right, they'll say, we're doing an update, and they don't tell you that in that update contains patches. So you don't even know that your stuff is being patched, right? Because they don't want to tell you that they had a problem, right? They're like, this is a feature enhancement, you know.
He utilized a lot of outside contracts.
Right.
Who they get the patches?
Right.
Who developed it?
Right. Well, we had that discussion.
You know that.
Right. Right. We discussed that in a leadership meeting yesterday, right? About the right to repair and who has it, right? And manufacturers are fighting. They would like you to believe that their stuff works by magic, right? And there's nobody else in the world that can do it. I work for a manufacturer. The training is not that good, right? You know, it's just not any different than I got better training at the hospital. I gave my staff better training. I had to because I was competing against the manufacturer who had, you know, they were already a step up because of who they were and what they did. Right. Here's another one, right? In 2020 in Dusseldorf, right? I don't know, this made the news. It was a pretty big splash for what it says on the bottom. This was the first time they initiated a homicide investigation due to a ransomware attack on the Dusseldorf. So University of Dusseldorf Hospital, this woman had an aortic aneurysm, right? And the university was under attack, right? They didn't have their imaging systems online. Their RIS and their PACS were off, as well as their EHR was offline. So they're like, we're on divert, right? So the ambulance had to take this woman to a different hospital, right? 20 clicks away, I think 20 miles, 32 clicks away, right? And she passed away, right? So they were like, oh my God, this is awful. And the interesting thing was, right, this was a Russian hacker group that got in there. They had no intention of impacting patient care services. And they felt so bad, they're like, here's the key, right? Restore your systems. They felt so bad. I mean, it was, you know, they had a conscience, believe it or not, you know, but the woman died anyway. They initiated a thing, and the outcome was, right, given her condition with the aortic aneurysm, they were like, she probably would have passed away regardless of which hospital she landed in, right? So they didn't pursue that, right? But this was the first time, right? Made big news here. So medical devices, we started to talk about this earlier, right? So medical devices are purpose built, right? Here's the thing, they interact with the environment just like every other IoT device, right? Whether it's a temperature sensor, a camera, right? They can sense or act on the environment. The difference is the environment is often a human, right? And so now it makes it, you know, very, very sensitive for us. So that's they're designed for precision and reliability. Can I do the same thing over and over again and get the same output over and over again? They're great at this, man. And if you ever looked at the specs on med devices, they're like that far less than mil spec, you know, for the military, like operate anywhere. These things will operate, you know, in the Arctic, in the Sahara, in the middle of the Brazilian jungle. You know, I mean, it's phenomenal, you know, what these manufacturers are creating. But the thing is, that means that they're rigid. They're not very adaptable. And that's a challenge that we have. So any changes that they want to make, you know, now we have to go through what they call V&V, validation and verification, right? That we didn't make any changes, you know, and that everything works as it's supposed to work, right? So it's a long drawn out process. There's a lot of technology debt, right? And there's life cycle disparity, right? So IT replaces your computers every 3, 4, 5 years, right? In AHA, the average expected life cycle of a medical device is either 7 or 12 years, right? So now we have these devices that cost an arm and a leg, right? They're still performing the clinical functionality that we bought them for, but they're on a Windows 10 or a Windows 7 operating system or Windows XP, right? I would prefer Windows XP. Nobody knows anything about it anymore, right? Exactly, exactly.
Like, say, yeah, they running this, we already know the book, so.
So, and here I'm just going to throw number 5 out here, right? And I talked about the transparency thing. It works by magic. You know, it's black magic. You don't have a right to know. You don't need to know, right? But the last one is software as a medical device. And I say this biomeds, the HTM community is very good at counting and tracking assets, right? But software as a medical device is kind of ethereal. It can be on anything. It can be on your phone, on your laptop, on his phone, you know, so it can chase around. So you can have the same asset deployed. You've got licensing issues. We're going to have to figure this out as this expands more and more, right, in here. The other thing is we have modalities. We often talk about medical devices as if they were chairs in a room, right? Like they all do the same thing, right? We have 4 major modalities between imaging and how many sub modalities for imaging. There's MR, ultrasound, how many different kinds of ultrasound, right? There's CT, there's PET CT, you know, there's PET, there's MR, and nuclear med, right? There's just all these things, right? In there, and monitoring, therapeutic, diagnostic, all gets there. In healthcare, there's also the IoT stuff, and it's just as susceptible, has the same challenges, and we often ignore that as well. Yes, sir.
Can you explain what IoT is for some of us? I'm a radiology guy, so.
Yeah. So great question. So it's Internet of Things, right? So this is a what they call a cyber physical device, one of those devices that interacts with the environment and also connects to the internet, has exposure to the internet. I've got a different slide that talks about that in a little bit more detail, right? That'll kind of fill in the gaps there. But yeah. So IoT, but think about this. This is, you know, the Target breach. You know, it was a vendor came in through the HVAC system, right? So that's an IoT device, right? How do you keep it cool, right? You've got isolation rooms that have positive pressure, right? That has to be maintained, right? In a hospital, you lose your positive pressure, you've got no more, you know, biological isolation in those rooms, and you're shutting down that department. People are leaving the hospital, right? They're fleeing. You know, so you've got fire control systems. A lot of this is life safety. IT treats risk differently than the rest of healthcare. Healthcare operates on the environment of care, right? Which is really about patient safety, and rightly so. And then IT comes in and chases threats and vulnerabilities. And you're like, what the heck are those? I don't even get it. And they can't correlate it. They don't do a very good job of correlating it. So we've got that friction that's caused because we're managing risk differently, and we have different views there, right? So here, and stuff like, I love this example, right? Because back when I was turning a wrench, you know, an anesthesia cart was purely a pneumatic system. You know, it was a billows and pumps and tubing and, you know, control valves, right? And now it's completely electronically controlled, connected to, you know, our EHR and our scheduling system for the surgery services and all of that, right? So we've created all these connections that create pathways into our environment, right? Increases what they call the threat surface, right? On here, monitoring PACS. I mean, who thought about calibrating monitors, right? But for medical imaging, you've got to calibrate them. You got to make sure that the image they display is the image based on the data collected by the diagnostic device, right? And we were just talking about that new CT technology, ion detection, right? That's supposed to, and this is kind of cool, right? Because if you think about how X-rays work in digital X-ray, right? You've got these, what is it? Galenium. Yeah, it's a block of crystal, right? And what it does is it converts X-ray energy to light energy so that it can be detected by cameras, the same camera technology that's in your phone, you know, or in your Canon. So they have to actually detect that. Well, if you don't have to go through that step, then you don't have, it's kind of like the difference between a CD and a record player, right? The pure analog has a little bit more fidelity, right? Less chance of distortion. So that's the issue there. And there's pacemakers, right? We don't even go. And this is the one, this one right here is the one where we have patient hackers, right? So we have a lot of people that rely on insulin pumps, you know, these are diabetic patients that require insulin, right? And they're smart people and they're like, oh, let me see if I can muck with these things, you know, and then they do it and then they're like, hey, FDA, do you know, you know, and so this kind of got the whole thing started with the need for this, right? And interestingly enough, the glucose, the diabetes management systems was the first standard to come out, driven by a guy named Dr. Kleinoff out in up in UCSF, I think. I don't know if he's with UCSF or just in San Francisco, but yeah, pretty big stuff. Here's that Internet of Things, right? So it's the any of anything, right? Any place, anytime, anywhere, any network, you know, we've got it. I just learned of a technology, right? So you can have a printer in your environment, right? Even though it's hardwired in, chances are the wireless is still there, and a hacker, and you know, wireless means the signal is everywhere. So somebody could come in with a detector, pick that up, and they could access your printer without even you detecting it because they never accessed your network. You know, interestingly enough, it's a pretty weird thing. So lots of big stuff here. We hit, right, 192 billion in revenue in the US in 2023. Big bucks, right? $13,000 we spend on per patient, right? They tell me that 5% of patients in the United States make up about 80% of the cost they consume. So a lot of us don't spend $13,000. We know, you know, I'm pretty healthy. I'm not spending that much a month or a year, right? But there are folks that are consuming boku bucks. And my wife does, she works for United Healthcare and she does pharmacy plans. And she's telling me the prices of some of the medicines, it's just unbelievable. You know, here they're paying $60,000 a month for medicines, right? That's what, it's crazy. Pharmacy is big bucks. We're in the wrong business, by the way. Here's basic system, right? So we're talking about interoperability. We've got the VPN, the outside world, right? A firewall, right? Wireless infusion pumps, right? They really just go back to a drug library, right? And this is how we make sure that I don't put, you know, 10 milliliters instead of 1 milliliter of this medication into you so that I can't overdose you accidentally. Things like that, make sure that that all works. That's a very simple way, you know, to do this. And this is the access point, right? But this device is actually transmitting all out in this space, right? And it's going to hit the access point anyway, right? So there's that risk there. If we go a little bit farther, now it gets a little bit more. This is what your world operates in, right? You've got the RIS system, you've got your PAC system, you're sending stuff out to physicians' offices. You've got physicians doing treatment planning in their offices and bringing data into your system. It gets lots more interactions. And what I think about is every one of these, right? Every one of these lines is a boundary. And so the purpose, the thing to understand is, right, every boundary has a transaction across it. You need to understand that transaction, what kind of data is contained in there and what's necessary to protect it. Those are the two questions you need to ask, right? And the third question is what can go wrong if it goes wrong, right? So think about, that's how we think about that. You've got all that out, we're archiving or pushing out, right? And now more and more we're driving into the home environment. We're taking healthcare to the patients, right? I was just talking to somebody yesterday. They were down in Houston. They've got a huge Pill Hill. It's like, it's flat as can be, right? But all the hospitals are like here, and the rest of the city's like out there. And yeah, there's some hospitals out in the suburbs, right? But predominant medicine happens like they're all in this one little enclave of hospitals downtown. And I see it in Cincinnati and New York City and Detroit and everywhere else. They're called Pill Hills. And it used to be that, yeah, the university would set up a hospital and all the other hospitals will build their hospitals around that, you know, and that's where medicine happened in that community. And then we took it and we pushed it out to the payers, right? So when we changed, we had accountable care, we took it out to the payers and we're like, all right, we're going to build hospitals where people can pay because Medicare, Medicaid's not paying enough for us to keep our urban hospitals going. Right now we're taking healthcare into the home environment, right? A whole new realm of challenges and a lot more transactions across that, right? So you've got the patient home, the telehealth platform, so everything goes to the thing. You know, I've got a watch, talks to my phone, goes up to the cloud, comes back to the caregiver, comes back to the patient, Now we've got what was, a single device with a display on it. Now we've got 7 different technologies involved in all of this, right? As well as all the transport that happens between there. So tough stuff on there. So this just kind of tells you, I talked a little bit about the complexity of the medical device environment itself, right? And healthcare is just as hard, right? You work in a hospital, right? And just confirm this for me, right? A hospital operates more like a specialty mall than it does like a well-run organization, right? It's every department has its own singular purpose. They have their own special tools and techniques, and they used to have their own information systems that did it, right? And even you see this, like MRI, well, that's probably not bad. Nuke Med was different than like straight rad, right? And ultrasound had their own stuff, right? And then if you had different locations, so it's all out there, right? So you've got urban and teaching hospitals and teaching places, you've got such a transient population with students and professors and the research that goes on and who they want to share it. Like, who wants to hurt healthcare? We're just trying to help people, and they're like, yeah, but you got money, so we want you, right? Suburban and community hospitals, rural, critical access, tough, right? 25 beds or less, 100 miles to the next acute care treatment, right? Not an easy place. If they get reimbursed, right, for Medicare, Medicaid, right, at 1% above reasonable expenses, not even actual expenses, reasonable expenses. Hard to make a living at 1%, right? Can't even keep up with inflation, right? I worked for a 100+ hospital system. We had 380,000 medical devices in our system, and my job was doing the operational benchmarking for them, making sure that we were keeping them up and running and we had good quality and it wasn't costing us too much and all of that, right? And then our CISO said, what do we know about medical devices and cybersecurity? And this was 2013, right? And the answer was not a darn thing. Nobody does, right? So we had to figure out what we had. And we knew, we did a survey, figured out we had 100,000 connectable. So that's about 25% of the equipment population as a whole. Between the time I retired in 2017 and today, that number continues to grow. I've talked to places that 40% of their medical devices are connected, right? And it's just going to continue to grow. Things that used to not be connected are now connected. Think of OR tables, right? Think of patient beds. Patient bed used to be a bed. It just had foot pedals and you moved it up and down and you had clickers and rails and that was it. And now they weigh patients, they detect falls, they do all kinds. They exercise them, right? The sport beds that change the compression so that the folks that are in beds a long time don't get bed sores. I mean, amazing technology, love it, right? But it's all connected stuff, right? OR lights used to just be a light, right? Now it's the information center for the entire surgery. Everything goes through the OR lights, right? And the towers that are on there. So we talked about that, 500 makes and models, 1,200. The good thing is, and there's relief, right? So for the biomeds, right, the HTM folks, about 20% of your manufacturers. So out of the 500 manufacturers, about 20 manufacturers will make up 80% of equipment count, right? And that's because the single biggest device in a hospital, single biggest count of devices in a hospital is the infusion pump, right? So you have more infusion pumps than any other single device in a hospital, right? And then the other one is patient monitors, right? Almost every bed's got a patient monitor, it's a system. What's that? Oh yeah, yeah, yep, absolutely. So the FDA has about 560 product codes for software-enabled medical devices. This is distinct stuff, right? 560, not a chair, not a table, 560. If I go into a hospital, right, and talk to IT and be like, how many different modalities of stuff you have? They got like 20. They've got servers and laptops and desktops and access points and routers and things like that. There's not that much diversity there, right, as there is with these purpose-built devices, right? It makes it hard to quantify and therefore hard to gain for getting it taken care of, right? So the healthcare, St. Jude's, right? So this is just some of the stuff that's been on the news, you know, I mean, it's there all the time and it happens, right? So continue to pose safety threats. So the FDA, cybersecurity is patient safety. This is their tagline for 2024, right? And the FDA, right, last December, not December 23, December 22, they were granted statutory authority for cyber, right? Because previous to that, they only had statutory authority for safety, right? And cybersecurity wasn't in there. Now we knew there was a link, but they couldn't do anything about it, really. They could kind of influence manufacturers, but they didn't have it. Now they have it. They're like, hey, we know that this is an impact, right? Christian DeMeth down at UC San Diego, he's an ER doc. He's been looking at this. Last year, he released a report that said, if a hospital gets ransomed, right, it impacts not just that hospital, but all the other surrounding hospitals, because they're the ones that have to absorb that patient load, right? And chances are they're not ready for it because they're not used to it, right? That's not part of their average daily census, if you will, on there. So, but they have it so effective, March of 2023, they could now push this in. What I really like is they said, if a person can change the way a medical device operates in a way that you didn't anticipate, that's a quality issue and you have to fix it. So it went back to the safety and the quality thing, right? And they pushed it in there. With all of this different technology, it's very hard for them to say, well, you should have this and you should have that and all these controls. They used to spend, I mean, if you've been involved in the procurement of medical devices, you've had those arguments with your vendors. You know, they're like, well, why don't you have multi-factor authentication on a implantable cardiac pacemaker, right? Well, because there's no buttons to push on it, right? You know, I mean, it's things like that, but because we don't understand it. So it's there. This is a big step, right? Patient safety, secure. This is some of the highlights, right? So it's quality, secure product development lifecycle. And I mentioned this yesterday in the talk they did with UHS, right? That I expect to see, right? Because devices they made yesterday are not ever going to get through this approval process. So if they do their normal upgrade, they're going to have to upgrade all the stuff to get it through the cyber side, because that's never been evaluated before. Chances are this old technology is not going to go. It's going to take manufacturers a little bit of a time. I looked at last May, I looked at the approval rate in FDA 510K and PMA submissions, right? So 510K is the equivalent. If I make a device, you know, and then I make a new device and I say this device is just like that device, they'll be like, that's equivalence, goes through the 510K. It's meant to fast track it, right? They won't let that happen anymore. They'll be like, yeah, that's nice for clinical functionality. What about your cyber, right? So there's going to be a delay in new technologies coming out as manufacturers get to this, because until Congress granted them statutory authority for cyber, the manufacturers knew that the FDA really had no teeth, right? There is no teeth behind the growl around cybersecurity, right? Transparency and labeling, and this is kind of cool. So if somebody can make your device do something else, the FDA can say, instead of removing like your authority to your ability to market it, they can just say it's off label now, fix that, and then you can market it again. So that gives them the ability to pause. They do this with quality. We saw it with ICU Medical and their infusion pumps, right? When they had a quality issue. We're seeing it with Phillips and their ventilators with the foam, you know, and their masks on that. They're saying, stop, you're going to have to fix that. So they just say it's off label, instead of going through the whole process of saying, we made a mistake, you know, in our approval process. They just go, you just changed something that took it off label, so you got to fix that. And off label can be like, we approved it to do hand x-rays and you're saying that you're doing foot x-rays, right? It's good for foot x-rays. Sounds like the same thing to me, but they're like, nope, you were approved for this, you're not approved for that. That's off label, stop doing that, right? That's kind of how that works. The other nice thing, and I bring out threat modeling, security architecture, and cybersecurity testing, right? So this is the thing, this is where manufacturers have to put this into writing. what they saw as the threats to this device, what controls they built into the device, to manage those threats, right? And how did they verify that those were effective, right? Because we know that the manufacturers had to submit that to the FDA, you can ask for that, right? Now, they're not going to give you, and you probably wouldn't understand what their threat models, risk assessments look like. But one of the things I talk to manufacturers about is your customers are going to ask for it. Start having customer-facing documents that address these things so that you can have an assurance as a buyer that they've done the due diligence on the front end, right? Is the point there. Cybersecurity applies. This is one of those behinds, right? But what they did say, the only point I'll make here is that the more interfaces you have, Wi-Fi, Bluetooth, Zigbee, all the other emerging technologies, that just creates additional threat vectors that you need to address, right? And the interesting thing too was prior to cyber, the FDA only evaluated the device for what the manufacturer claimed it could do, right? So if it said, I can do chest x-rays, they did not evaluate it for ability to test to x-ray knees or any other part of the anatomy, right? It's just chest x-rays, right? And that's kind of a bad example, but I want to keep it simple, right? That. So with cyber, they're going to say they're going to evaluate the device for what it's capable of doing, right? Different than what you're asking approval for, right? And it kind of goes back to that off-label thing, right? If I do chest x-rays, I don't do hips, you're off-label for saying you can do hips. This is like, oh no, if you got a USB, even if you say you don't use it, it's a threat vector. You're going to have to control that, right? Provide controls for it. So that's kind of a new thing here. Observable stuff, we've all seen this. We know it's there. Quality, I mentioned this. This is great. I really like this, right? The security objectives. And this, even if you're an operator, you should be just these 5 things, right? Authenticity. How do I know that the person logging into my device is the person that they say they are? So how do I know you're authentic? And in today's AI, where you used to say have to ask, is this true? Now you have to ask, is this real, right? AI, like they can now take a spoken sentence and AI can, imitate a speech in your voice, with your inflection. So authorization, what you're authorized to do, right? So can I get into the system? Once I'm in the system, what can I do, right? I shouldn't have root access on here. Availability, confidentiality, and then secure and timely update and patchability. So the FDA had claimed, like, in its 2018 draft version of the pre-market stuff, they said manufacturers should be able to identify cybersecurity issues within 30 days and resolve it within 60 days. And not a single manufacturer has even come close to hitting that mark. It's more like 60 months, they're just not doing it. So they're really looking for people to build adaptability into their processes there. Right, quality, device intended use, the present and functionality of the interfaces. This is all stuff we talked about before. This is what I like too, the intended and the actual environment. When I first got involved with medical device manufacturers, I'd be like, well, hey, if your device fails, how does that impact patient care delivery in a hospital? And manufacturers would be like, I have no idea. How would I know that? I'm like, you're building this stuff to do this very specific job. I think that would be the first job you want to ask, right? And you guys will know it, the rad folks here, right? If you lose a CT out in your diagnostic imaging center, in suburbia, you may lose some revenue. It's a patient inconvenience because you got to reschedule them. Maybe you send them to the next community over, right? But if you lose that same make and model of CT in your ER goes on divert, right? You're losing 14 to 18% of your admits that come through there, and you're losing, it has a bigger financial impact, right? So same device, same loss, right? Can have 2 different impacts. And that's part of that whole IT and doesn't understand healthcare, right? Because my observation is the IT departments are most often found in the abandoned Sears building on the edge of town, right? That's where the data centers are. They're not typically not in the hospitals themselves there. So, and then exploitability. The thing with safety is there's always a predictability factor, right? It's an engineering problem, right? How long will this belt last before it fails? How long will this filter go before I have to clean it, on that? So these are engineering problems, right? How much heat can this capacitor take before it's going to burn open and shut my 5-volt VDC down, right? With cyber, there is an intent, a human element of intent that inserts chaos into that and makes it unpredictable. So this guy, Dr. Wasserman at the University of Kansas, is like, a cyber event or the possibility of a cyber event is 0 until it happens, and then it's 1, and it always has been 1, right? Because the possibility always existed, we just didn't know about it, right? An interesting way to think about the world and how that works, right? Kind of blows the whole, what's my percent of failure, right? We do that a lot. So alignment, this is a leave behind. It just says, hey, the pre-market guidance says this. This is what Congress granted or told the FDA that they have to do. And this is the FDA's response to it. If you haven't read the pre-market guidance, I know it's like 70 pages. It's probably worth a browse through. Unless you're operating in the field, then it's worth a good read, right? Cybersecurity, engineering is about making sure that certain things happen. Security is about making sure that certain things don't happen, right? So very, very tough to do here. And what a device can do versus what it's designed to do, right? And that's right out of that's FDA speak right there. I got that straight from Jessica at the FDA. So the SBOM, anybody know what an SBOM is? Anybody hear of it? Nobody, huh? Bomb. No. so here it is. Here's a simple version, right? SBOM is a bill of materials. It is simply a list of what's there. So I have a computer right up here, and it's got an operating system, it's got interfaces, it's got all of these software components that allow it to do all these amazing things like put a presentation up on the screen, right? Those components are the BOM components, the SBOM components, right? There's a hardware bill of materials. Are we out of time? No, 10 minutes? Okay, 10 minutes, okay, good. I got a lot to get through here. So this is that, just think about it here. This is one of the big elements. The FDA is telling manufacturers, you've got to make the SBOM available to your consumers, right? To your users. And it has to be in machine readable language, because think about this, right? 380,000 medical devices, 100,000 of them connected. This is asset management nightmare, right? So to every one of those 100,000 devices, add 5 to 1,800 software components in there, right? Asset management, unbelievable, nightmare, right? So that's the element there. Introducing, so Health ISAC, right? And many of you guys are members of Health ISAC. We built an SBOM repository to do the many-to-many to make it easier, right? So think about this, right? What was your name again? Your name? Able, that's right, Able. So Able works for a large hospital, right? If they have Log4j, right? One of these things that comes out, right? And then he has to contact 500 different manufacturers. Well, to understand whether Log4j exists in his equipment that he's responsible for, right? So if I can reduce that, if he can come to one place and cover 50 manufacturers, right? His life is simpler, right? It's more efficient, more effective. It'll be machine readable, all of that. We're building that. It's me, really, or Health ISAC, but me. This is the way I put it. It's me kicking the industry in the butt. We've been talking about SBOMs for like 7 years now with the NTIA and now CISA, and they're still not sharing them. So I'm like, let's get to it. We're not actually going to solve the problems of sharing SBOMs until we actually start sharing SBOMs. So we have a POC in place. We're working with it. I expect to have a dozen manufacturers by the end of the year and just build on that. And I don't think I'm going to be the only person, the only organization that does it, but I think Health ISAC is well positioned to lead this effort, right? Free access for all HDOs. So even if you're an HDO and you're not a member, because I know that not all HDO members are Health ISAC members, or all HDOs are not all Health ISAC members, but it doesn't mean you're not the customers of your manufacturer. So you can get access to them there. You don't need to see that. That's just a fancy slide. So here's an interesting one. This is the one that always breaks my heart, right? Down in Spring Hill Medical Center, Alabama, I believe, right? A woman went in, she's like, hey, I'm getting close to term, you know, we're maybe a little past term. They're like, hey, come on in, we'll induce if necessary, right? The hospital, Spring Hill Medical Center, had been under ransom attack for 8 days when she went through admissions and they brought her in, right? So the real thing was, right, July 19th, so the mother was not informed, right? 8 days into the attack, right? There's fetal distress not detected. You know, if you've been through the parenting process, right, or the birthing process, they put a toco transducer on the mother's womb, right? And that monitors the infant inside, right, prior to birth, looking for, you know, everything, right? Umbilical wrap is fairly common. It happens in about 10% of the births, right? But because it's detected, because of the technology we have, it's a non-issue. You know, you rarely hear this. Well, because they didn't have central monitoring on that. They had monitoring in the room, but it wasn't going to a central place. They didn't have enough staff in the hospital in there to cover that, right? It wasn't detected, right? And the baby was born, resuscitated, right? And 9 months later passed away, right? So yeah, very sad. Probably with brain damage from lack of oxygen, was never going to be a fully healthy person, you know, just a tragedy all the way around, right? But it was the first condemned, and even though this happened in 2019, right, there's still not a final ruling as to whether Spring Hill, you know, Medical Center was out on this. So we're still waiting to see, but this is the impact, right? Even folks, they're like the folks in Dusseldorf, they're hackers they can't tell the difference, right? IT used to do updates and they'd be like, oh, my interventional lab just rebooted in the middle because they updated it and had to restart the computer right in the middle of an intervention, you know, and you've got a stent, you know, halfway up to the heart, and it's like, oh, look at this, we'll wait a little bit before we continue. So my point is, right, these are IT people, they can't tell the difference between a CT workstation that's running Windows or Linux, right, or a regular workstation in the administration office that's running Windows or Linux, right? It doesn't look any different on the wire. It's just got different applications on it. So that's the challenge, and that's really what we have to protect here. So this is for the biomeds in the room, right? Because this is the thing, right? So my thing is this, right? Ransomware is a failure mode, right? It's just a way for things not to do what they're supposed to do. So that makes it an HTM responsibility. It's not IT's responsibility. You don't even want IT, you know, to put on a bunny suit, right? And go into the OR while there's a patient open on a table to figure out what's going on with an image guidance system, right? That's biomed's job at all. But biomeds have to kind of expand the thing, right? So we're responsible for keeping things running. We now have to take part of the responsibility for keeping things talking, because that's traditionally IT's role, right? So we need to step into that. So because it's a failure mode, think about what happens when devices fail, and then how are you going to recover from that? So think about this, right? You have a CT, right? If your CT pops, there's a couple things. A, you probably anticipate it because it starts to spit a little bit and the images got a little wanky, right? Ahead of time. So you're already thinking this tube's on its way out. But when it finally pops, right, you know where you're going to get the tube from, how long it's going to take to land on your dock, how long it's going to take you to install it and calibrate it, and when you can return that to clinical service, right? And when it fails, you can tell the radiology director, right, Greg over here, you can say, I'll have you back up and running by noon tomorrow morning, right? So if your hard drive fails, what are you going to do? If your hard drive gets ransomed, what are you going to do? Right? Right, there you go. There you go. So if you're like many people, if you're like many people, you're going to go to that box of discs that the OEM left with you that have been in the cabinet, and you know you're going to dust off the dust that's on it that's been there for 6 years, right? And you're going to reload that, and then you're going to contact the manufacturer and you're going to ask them, you know, what are all the updates that have been done on this device? What are all the configuration settings that have been done on this device? So the strategy I used to use at CHI, and we did this because of Configure, right? Anybody hear of Configure? It's an old nasty little worm that used to run around and get everywhere, right? And it just was an infectious little beast, right? But no doubt I probably 6 times this happened to me. An OEM service engineer would walk in to do an update on the device, and he had let his daughter borrow the USB or his son borrow the USB, and they went out and played games and they had infected, right? And it infected my devices. So I started ghosting hard drives for all our critical stuff. And then I would wipe all the patient data off it and ghost it again, right? And then once a year, I would go through that process, right? So I kept a backup right there, right? And when I lost a hard drive because of this, I'd bring it in, pop it in, I'm back up, and then do the updates, and chances are I'm back up and running in like 4 hours, right? So I thought about how can these devices fail, and I didn't care whether if the device failed because the platter went corrupt or whether it was ransomware. I could actually pull the ransomed hardware out, hand it to IT so they could do their forensic analysis, and I could still get my director back up and running in a reasonable amount of time. So we just have to start thinking about things a little differently, and that's really the challenge that we have here, right? Complicated life cycle medical devices. And just to let you know, right, so this is the supplier, the folks that make the software that manufacturers select to put in their devices, right? This is the manufacturer's whole thing, and there's a whole bunch of stuff on here, right? And then the maintenance. So we talk about HTM and IT in a hospital not working well together, not playing in the same sandbox very well, right? If you go to product development in a manufacturer and product support in a manufacturer, same dysfunction, right? Like the sharks and the jets in West Side Story. It's crazy, right? So we won't spend a lot of time there, right? Security program, anybody that's run a maintenance operations program will recognize this wheel. Governance, right? Secure procurement, how do I maintain it? How do I monitor it for health? How do I respond to it? And how do I get rid of it? And here's the thing I'm going to challenge you folks to, right? As you bring new devices into your environment, say, how are we going to eliminate the risk that is residual on this device when it leaves my enterprise in 10 or 12 years after I've retired, right? So that's the thing. We've all heard the stories about we rent or lease printers, right? And everything you sent to a printer not only comes out in paper, right? But it also gets stored on the hard drive, and eventually it's what they called FIFO, first in, first out, right? So when the hard drive is full, but it's got thousands of records on there. And then when we switch from Toshiba to Canon, right, we give Toshiba back all of our sensitive information that we've sent to that printer, right? It's crazy. It's crazy. So we have to think about how can I dispose of that on things like CTs and MRs, right? We were putting second hard drives in there because they all had a secondary drop in there. So we would put a second drive, and all the patient data would go to that other hard drive. So I kept the operating system and the clinical application completely separated from the patient data. I could drop one out. So that way, when I went to trade it in, or what we were doing, right? Because we decided, oh, we're going to be cardiac giants, right? Yep. 2 minutes. Yep. Thank you, though. So I know it. So we're going to be cardiac giants, right? And they would, and we were downstreaming. So we take a 16 slice CT that was 2 years old, and we send it to that critical access facility that would never be able to afford that CT, right? And we give them that and we put that 64 slice CT in the other place, right? But the thing is, even in the same healthcare system, I can't transfer that patient data to that other place. There was no clinical need for them to have that, right? And so I had to have a way to do that. And that was one of the strategies we picked there, right? This is just details around this. Safety and security are interlinked, right? The big key here, right? Asset management, it's all about that. Secure procurement, there's not enough. These are all leave behinds. The RACI, I will say this, right? This is the best tool to figure this out, right? These are the doers across the top, right? And then the tasks that need to be done. And RACI is just a role assignment. Who's responsible for doing it? Who's the decision maker? Who needs to be informed? Who needs to be consulted? That's RACI, responsible, informed, consulted, and accountable, right? So set one of these up for everything. So if you're interested in learning more about cybersecurity, right? XPS Cert is looking to get people certified, right? And you can get a certificate of cybersecurity for free, right? Take the course for free. It's like $200 to take the test, right? And you get a certificate in cybersecurity. They're doing like 1 million people. That's their goal, is to get 1 million people certified because of the shortage in this space. Yes, sir.
Well, they split off and use, I wrote it down, system security certified practitioner. That's part of ISC.
So yes, they have a whole bunch of them, you know, and there's like CISSP, there's HISSP. I think they actually took that off, but there's many, many certifications. You can get Windows certified, you can get Novell certified on there. This is me, a little bit more about me, my email, my phone number. I have an open door policy. Just give me a call, shoot me an email. We'll get on the call. We'll talk about whatever you want. My job is to build community, right? And help people solve the problems that are challenging.